Okay, ladies and gentlemen, let's take a look real quickly. Had a couple requests about not sure how to get started on some of the verifying identities. So let's go through a couple of these and let's look not so much at all the details of getting everything done, but let's look at how do I get started? What should I do first? In this case, if I'm at number one here, the very first thing I ought to notice is that I have a Pythagorean property. So if I start with a Pythagorean property and I say tan squared theta cosine squared theta equals sine squared theta, the first thing I'm going to do here is change it to tan. And now since this is sines and cosines, I probably want to move everything to sines and cosines. Number two, I have tans. So probably what I need to do here is, again, I see a Pythagorean theorem. So I'm going to replace this with sine squared theta. And now I can take secant. Secant goes to cosine. I got sine squared. Sines and cosines make up a tangent. Down here, we have something a little different. I don't have any cubes. I don't have any properties, so I don't want to start there. But I do have a sine in each place. And with a sine in each place, I can factor out a sine, and that leaves me 1 minus cosine squared theta. Well, that's good news because that is a Pythagorean theorem. Here, I have only sine over here, so probably a good bet is to change everything over here to sines and cosines. So I end up with something like this. Well, with that, I have common denominators moved from there. 5, I have a cotangent squared in both cases, so let's take a cotangent squared out. That leaves cosecant squared theta minus 1. That's a property. Number 6, again, I have tan in both places. If I take a tan theta out, that leaves cosecant squared theta minus 1. That right there is a property. I need to be able to see those things. Here, I have two fractions. Two fractions means I'm probably going to go finding common denominators. And once I find common denominators, I'm good to go. 8, we already did in class. 9, first thing I'm going to do is I'm probably going to take this and change this to sine theta over cosine theta. And once I have that, get common denominators. Cosine theta. Here it's going to be different. Common denominators, put them together. Number 10, there's already a video on, so go see number 10. It's already on a special video of its own. 11 you don't have to do, but that's a property. That's a property. Change this to something that might be more useful, or worst case scenario, get common denominators and see if you can get rid of stuff, because I know if I'm going to have a 1 somewhere, Pythagorean theorem. Here, common denominators. Here, if you FOIL this out, it's going to go away and make 1 as it is. As soon as you see to the 4th and to the 4th, I'm going to break it up and I'm going to say squared and squared. So I'm going to say cosine squared of theta minus sine squared theta. And then I'm going to say cosine squared theta plus sine squared theta. Here, common denominators. Here, common denominators. Here, I have 4th powers again. I'm going to break them up half and half. Here, if I gave you this, x squared plus 2x minus 3 over x squared minus 1, how would you factor it using straight up x's and now do it with cosines and secants? Let's go over here. Number 20, I know I need sine. So probably I'm going to FOIL stuff together first, and once I've FOILed it out, change it all to sines and cosines. Down here, ooh, this is kind of nasty. I have a times and I have a plus or minus. Well, let's see here. I know that I can change tangents into sine squared theta over cosine squared theta. Here, minus sine squared theta over 1, and now work on getting common denominators and then factor out some stuff. So common denominators and factor, you're going to get a nice Pythagorean. It's going to work out well. Here, these are all cosines. These are not. Well, change this into something that might be sine or cosine. Find common denominators. And be honest, 22 is a long one. But again, there's a video to it. 24, I would first start by foiling that dude out because I know Pythagorean theorem is going to take care of part of my problems. But in this case, I'm probably also going to maybe have to work with the conjugate over here. This may be one where I have to work both sides down and see if I can make them meet in the middle. Over here, 26. Again, it's going to be very similar to working on 21. Probably going to need to get some common denominator. Actually, this is super easy. I can just say sine squared theta over cosine squared theta times cosine squared theta. Boom, boom, sine squared. Well, wait a minute. What's on the other side? Sine squared. Well, that's easy one. Okay. Down here, probably going to need to get sines and cosines, combine fractions. So use reciprocal, combine fractions. Here again, I got a secant in both places. We talked about something very similar to this in class. 2 minus secant squared theta. Take out a secant squared. That's where I would start. Then I got 30. 30, oh, yuck. Well, 30 probably I'm going to need, that's a tough one. But maybe what I ought to do is I ought to find 1 plus sine theta over cosine theta. Oh, yep, this will work nicely. Over sine theta plus cosine theta. And put that over 1, multiply by reciprocal. See if that works for you. In this case, I would split it up into 2 pieces. And by splitting it up into 2 pieces, I'm going to come up with 2 over cosecant theta. Secant theta plus cosecant theta secant theta over cosecant theta secant theta. And those are going to go away and make 1. These will switch and turn into 2. Sine theta cosine theta plus 1. And I think when you multiply that, this will look familiar. So again, working both sides, see if you can bring them together. 32, we already did that in class. Let's move on down here. 40, we already did that in class. Get sines and cosines together, and when they do, they simplify out. Ladies and gentlemen, these are natural logs. If I have ln of A plus ln of B, that's the same thing of ln of A times B. So if I have A times B, this is going to work out really nicely. So I end up with the natural log of cosecant x, or cosecant squared x minus cotangent squared x. And ladies and gentlemen, I shouldn't have to tell you too much about that. And you need to know what the ln of 1 is. Down here, 44. Again, you have fourth power, so you're going to break them up left and right. Okay, so from there, you should be able to do some of these problems. So that should get you a good start on all of them. Okay, if you have any questions, of course, what do? You email me. You come in before school, 7:15 every morning. I'm in the front hallway, before school, after school. So take a look.